All right, guys, I promise you will be 2 days doing some of this stuff. Make sure you get it. So I'm going to shorter video, hopefully today, just more on what we did in class today, more trig identities, a couple more strategies. All right, I put this back up here. These are all the identities we've been using. Used these yesterday. We're going to use them again today. Not a bad idea to have a picture of that somewhere just so that you have them. Okay, so you need to either know all those, have access to them. Those are the fundamental ones we're using to prove new ones. So make sure you have that. All right, two more new strategies. One is adding something new. So let's say here's my identity, and I got to prove. I'm going to take the left-hand side, try to make it look like the right-hand side. So I'm going to have this cosine. They used u. I'm going to use x. Cosine x over 1 minus sine x. And I'm going to make that try to look like secant plus tangent of x. All right, so what you can do when you have a denominator like this one, because there's nothing, just looking at that, there's nothing to do. Right? There's no moves to make. So what you can do is there's always this option to multiply by the conjugate at the bottom. The conjugate of 1 minus sine x is 1 plus sine x. And if you do that, your numerator is going to look like, it's just cosine x times 1 plus sine x. I'm not going to distribute that yet because I'm hoping I can cancel something later. My denominator is now 1 minus sine squared, which is really nice. The reason that's nice is because that's so familiar to me, because 1 minus sine squared is really cosine squared, and that's from that first identity. So I have cosine x over 1 plus sine x over that cosine squared. Now, because I have a cosine in my numerator and a cosine squared in the denominator, they cancel. Okay, so that gives me this. It gives me 1 plus sine x over cosine x, which is awesome. And here's why. And this is a trick you can use a lot when you need to. Whenever you just have one term in your denominator and more than one in your numerator, I'm just going to draw arrows this way. You can rewrite it like this. You can break that up into two pieces, like 1 over cosine x plus sine x over cosine x. You can break that into two fractions. So I just want to say cosine, by the way. Now, the cool thing about that is, look what I'm trying to come up with. I'm trying to get secant, which is what that fraction is. And I'm also trying to get tangent, which is what that fraction is. So I did it. Okay? Showed every step. Not that big a deal. But the key was the new thing today, one new strategy that I didn't show you yesterday, is you can multiply by the conjugate when you have two terms in your denominator. And don't forget this little piece here. When you have one term in your denominator, you can always split it up into parts. All right, guys, there are times, and it's not very often at all, when you can take one side. It's just, put it this way, it's impossible sometimes for me to take this side right here and make it look like that side right there. Like, you just can't do it. That doesn't mean there's no solution. That means you need to break down both sides. It's rare, and you don't know it when you start. You just kind of discover it as you go. So let me show you this one. Let me show you what I'm talking about. I'm going to take this side right here and just go as far as I can go. Okay, so we just did this. There's just one term on the bottom, so I'm going to break that up into two different fractions, like this, cosine x over, cosine x there. So that gives me 1 over cosine is really secant, and cosine over cosine is 1. And that's all I can, there's nowhere to go from there. And that doesn't equal the other side. So now I'm going to take this side and see if I can make it become secant x plus 1. And if I can, then I've verified that those two sides are equal to each other, so that is an identity. Okay, so I'm going to pull a trick out of my hat right here. Tangent squared. Notice what I want. I want to get a secant and a plus 1. I don't want tangents anywhere. And here's what I know. I know from way back that tangent squared, and it's on your first slide today, tangent squared plus 1 is secant squared, which means tangent squared is secant squared minus 1. So I'm going to take that tangent on top and make it say secant squared minus 1. That just rearranged that Pythagorean one. Now, on top up here, that's the difference of squares. I can factor that like secant x plus 1, secant x minus 1. And in my denominator, I have secant x minus 1, which is convenient because what happens is they cancel. When they cancel, it leaves me, guess what it leaves me with? You guessed it, secant x plus 1. Look up there. They're the same. Got it. Now, you're only allowed to do that method if nothing else works. All right, and you have to try something. To keep the video short, I didn't actually try to make it look like that side so much because I knew what was going to happen. But you just got to try your best. If you just get stuck, then take the other side and go from there. But we the goal number one is try to make one side look like the other. All right, so hope that makes some sense. We'll probably work on a couple of those tomorrow in class. Can't wait to see you then. See you, bye.